Hello and welcome to Golden Geography. Today we're going to be thinking a little bit about human activity in a periglacial landscape. And we're going to be focusing on the Trans-Alaskan Pipeline. It fits into this part of the specification, which is a case study of one periglacial landscape that's used by people to illustrate the human activity taking place and why it's taking place, the impact on processes and flows of materials, the effect that has on the periglacial landforms, and the consequences of those on the landscape. So first of all, a little reminder about what periglacial landscapes are. Peri means next to, so these are landscapes that are next to glaciated environments. They are indicated on the map in purple. They very often have permafrost as a key component, and we'll come back to that a little bit later on. But these areas may be covered with snow for 6, 7, 8, 9, 10 months of the year, but the difference to a glacial environment is that for at least 2 or 3 months of the year, temperatures will rise above 0 degrees centigrade, and as a result of that, the snow will melt and the ice will melt. So for a small period of time, these are ice-free environments, whereas glacial environments have ice at all times. So we mentioned permafrost already. These periglacial environments have a tundra biome, and that's very much influenced by the permafrost beneath it. Permafrost means permanently frozen ground. So the ground, the water within the ground is frozen solid. Now this can vary. The top diagram we have here shows a continuum. Closer to the poles, we have continuous permafrost where the entire ground is frozen. Slightly further south, perhaps even further south than the Arctic Circle, we will find that actually we get areas of permafrost but also unfrozen ground, and that unfrozen ground is called talc, and we can see through talc and closed talc on the diagram, and then we get areas where we have predominance of talc and small areas of permafrost, and that's called discontinuous permafrost. Areas which have discontinuous permafrost have a slightly different biome. You'll start to find trees there. But areas with continuous permafrost will be treeless, and that's part of its definition. So we're going to have a little look at the human activity that's taking place and why it's taking place in this very unique and precious environment. And we're going to talk a little bit about the Beaufort Sea. Beaufort Sea is found off the northern coastline of Alaska and Canada, and it is oil rich. There are oil companies there extracting oil, particularly off the Alaskan coastline. And that is really important for America, United States, in terms of its energy security, providing oil to the US for a vast number of reasons. But because of the challenges of the environment it's in, a lot of the gas, and oil and gas are found together in deposits, the gas is not wanted, it doesn't have as high a demand. So the easiest thing to do with the gas is to flare it off. And that flaring of gas can change the temperature of that environment. Well, the oil is then transported via the pipeline, and you can see here the pipeline runs all the way across Alaska from the northern slope right the way down to Valdez. So from Prudhoe Bay in the north all the way down to Valdez in the south, where it is then put on a boat and shipped to central USA, where it is then used. But this is a significant human activity. The development, the building of this has been quite challenging. It has been there for well over 40 years. I suggest you pause the video, use the QR code to watch a little summary of what's happened over the last 40 years for this pipeline. So what has this pipeline done in terms of the processes and flows within this periglacial environment? Well, we've already mentioned the flaring, and that flaring, the burning off of the gas found in the same deposit as the oil, does mean that there is an increase in temperature. Periglacial environments are very sensitive to temperature, and as soon as you start doing any kind of activity that increases that, you will see an impact. So the flaring has increased the temperature, and both the construction and the movement of the oil through the pipeline has altered the environment too. It has changed the thermal energy within this environment, even though steps were taken during the construction to prevent or to limit the amount of energy and heat within this landscape. The very fact it's there has changed it. So what has it actually done? Well, in terms of the water cycle, if we think about the processes and the flows, well, that increase in thermal energy means that actually those flows, those processes and flows, things like evaporation and precipitation, are happening a lot more. We're getting more runoff because the environment is warmer. If we think a little bit about the carbon cycle, as this environment is warming, that permafrost, particularly the active layer, is melting and it is releasing stored carbon, particularly in the form of methane, into the atmosphere. So we have much more taking place in terms of the movement within the carbon cycle. It's not just the release of methane, we have more biomass. The growth of biomass is taking place much quicker because there's more carbon in the atmosphere. Those warmer temperatures are also meaning that decomposition is increasing. These are processes that did happen but were incredibly slow. But this warmer environment means that it's taking place a lot quicker. If we think about the stores, well, the water cycle, most of that water is stored in the permafrost. And as we've already mentioned, that permafrost is thawing, and we're having less and less continuous permafrost, more discontinuous permafrost. And that is releasing water and increasing runoff and saturation within the soils, development of lakes, as we'll talk about a little bit later. So the stores are changing from a solid to a much more liquid form of a store. And the carbon that's stored within that permafrost is being released. Carbon that's stored within any ice is also, that ice is melting, it's being released too. So we've got a change in the stores. In summary, for both the water and carbon cycle, the processes and flows are increasing, the stores are decreasing. Which brings us to this question of equilibrium. Is this environment in equilibrium? In a natural state, yes, it should be. But as we're adding in human activity, that balance, that equilibrium, is changing. So no longer are we finding that we have equilibrium. And that's kind of triggering feedback loops or feedback cycles. And you can see some examples on the side here. You can have positive or negative. Positive feedback cycles often lead to a change away from that equilibrium that can be permanent, especially if it goes beyond a tipping point, and we are seeing that within our periglacial environments. We can get negative feedback cycles, and that should restore your equilibrium, but that's not happening quite as much. If we think specifically about our tundra and our permafrost, the green diagram shows us that actually our human activity is causing rising temperatures. Those rising atmospheric temperatures is warming the tundra, the biomass that we've got there. It's changing the permafrost and the active layer. It's melting and thawing that permafrost, which in itself is releasing carbon, particularly in the form of methane. And methane is much, much stronger as a greenhouse gas than carbon dioxide. And that in itself is then being absorbed into the atmosphere and causing a warming of the atmosphere. So this positive feedback cycle is having quite a dramatic effect on the landscape in this periglacial environment. So what is it doing? Well, it is changing our permafrost. The active layer particularly is melting for longer periods of time. So rather than just a couple of months a year, it might be 6 months of the year that that active layer is melting. The permafrost is melting and thawing and becoming discontinuous rather than continuous. And that is changing some of the landscapes around it. We can see here an image representing deglaciation at the end of the last ice age, but the same thing is happening or being observed in our periglacial environments today. So we are finding that the permafrost is melting, that we get ice wedges as well in permafrost that are melting away. The active layer is becoming deeper. The active layer is becoming more waterlogged. We have much more surface runoff. We've got much more channelization and lakes developing in this environment because of the human activity. And as a consequence, we are seeing changes. These are all images that are showing you the changes that are happening to our landscapes because of permafrost thaw. Here again, another image which shows us what is happening as a result. So at the top we've got stable permafrost, at the bottom we've got thawing permafrost, and a lot of that leads to subsidence, which can be a problem for any kind of human activity, whether that be roads and railways, buildings. Any activity becomes much more difficult once you have unstable thawing permafrost. Those impacts include drunken forests, subsidence that is evident in our buildings, and the release of methane, which of course triggers that feedback system, that positive feedback system. And when we're looking at areas at risk, the areas that are getting warmer quickest are within the northern parts of Alaska, between Fairbanks and Point Lay. And if you have a little look at some of the cities in those areas, they're the ones that are starting to experience subsidence. So make sure you know a name of a few places like Barrow or Prudhoe Bay. These areas are starting to have some of the greatest changes because of the permafrost and the thaw that we find in it. So what is it doing to the landscape? Well, we're finding thermokarsts develop. Thermokarsts are effectively just lakes. The surface is becoming really waterlogged, and these thermokarsts are developing. They're about 5 meters deep, maybe a couple of kilometers wide, so they are quite shallow. We also get alasses. Alasses are very similar, but a lot bigger, a lot deeper, and a lot bigger, but they can be a little bit more kind of seasonal or temporary. But these thermokarsts and alasses are indicators of our changing climate and the impact we are having on it. Okay, quiz time. Pause the video, see if you can answer these quiz questions. Here's the answers. If you got any wrong, just pause the video, have a little rewind and have a look at the information again. And here's a potential essay question. Now I say potential because the question is about glaciated landscape systems. So ideally you would be talking about glaciated landscapes and you'd be talking about the dam in Switzerland. Different video for that one. Really, you would want to see the words periglacial landscape system for the Trans-Alaskan Pipeline, but there is a little bit of flexibility. And I'm sure if you were to kind of explain those, that you could write about the pipeline as well. So you could have a question here where you have paragraph 1 looking at human activity in a glacial landscape, the dam, paragraph 2 looking at the Trans-Alaskan Pipeline in a periglacial, and discuss the human activity and the physical factors in both of those situations. Don't forget, this could be a shorter answer question too. Thanks for listening.